Hi everyone, welcome back to my videos. So let's solve two algebra problems here that have appeared on the kangaroo competition. So given this equation here, x squared minus 4x plus 5 to the power of x squared plus x minus 30, and this is equal to 1, how many different real solutions does this equation have? So we can use the trick here. We use the fact that e raised to ln of x is equal to x, and that e to the 0 power is equal to 1. So I'm going to rewrite the left side of the equation as e to the ln x squared minus 4x plus 5 times x squared plus x minus 30. So using this property, this would drop this into the lower position, right? And then 1 is equal to e to the 0, so we can solve this equation here. So now all we have to do is solve x squared plus x minus 30 times ln of x squared minus 4x plus 5 is equal to 0. So before we do that, we want to check that x squared minus 4x plus 5 is greater than 0, because ln is only defined when its values are bigger than 0. So we can't have this equals 0 or this thing less than or equal less than 0. So what I can do is x squared minus 4x plus 5 is I can kind of complete the square, and then we get this kind of standard equation for a parabola, right? X minus 2 squared plus 1. So this is, like I said, this is the equation of a parabola, and it opens upward and has a vertex at x equals 2, y is equal to 1. So because of that, x squared minus 4x plus 5 is greater than or equal to 1, which is consequently bigger than 0 for all x, all real values of x. So we don't have to worry about x squared minus 4x plus 5 being less than or equal to 0. So let's go ahead and solve this. X squared plus x minus 30, so we're going to solve this equal to 0. We can factorize that as x plus 6 times x minus 5 is and set that equal to 0. That gives x is equal to 5, or x is equal to minus 6. So we can check, since we know the ln is going to be defined for all values of x, then we can include positive and negative values, so these two values work. And then we're going to set ln x squared minus 4x plus 5 is equal to 0. So since ln of 1 is equal to 0, we have to solve x squared minus 4x plus 5 is equal to 1. So just put the 1 on the other side, and we get x squared minus 4x plus 4 is equal to 0. And that is x minus 2 squared is equal to 0, so x is equal to 2. So this equation, x squared plus x minus 30 times ln of x squared minus 4x plus 5 equals 0, has three solutions. X equals minus 6, x equals 2, and x is equal to 5. So the original equation that we want to solve has three real solutions. Okay, so let's do problem 25 from the 2016 Kangaroo. Given x squared plus ax plus b equals 0, and x squared plus bx plus a equals 0 both have real solutions, the sum of the squares of the solution of the first equation equals the sum of the squares of the solutions of the second equation. And we also know that a is not equal to b. Find the value of a plus b. So we're going to let x1 and x2 be the solutions of x squared plus ax plus b equals 0, and we'll let x3, x4 be solutions of x squared plus bx plus a is equal to 0. So in general, if xa and xb are the solutions of a quadratic equation, then x squared minus the sum of the solutions times x plus the product of the solutions is equal to 0. So what do we know? We know that x1 plus x2 equals minus a, x3 plus x4 equals minus b, x1 times x2 is equal to b, and x3 times x4 is equal to a. So what I can do is I can square x1 plus x2. So we get x1 plus x2 squared is equal to minus a squared. And if we expand that, we get x1 squared plus 2 times x1 times x2 plus x2 squared is equal to a squared. We can do the same for the equation x3 plus x4 equals minus b. So x3 plus x4 squared equals minus b squared. So that's equal to x3 squared plus 2 times x3 times x4 plus x4 squared is equal to b squared. Now we know the sum of the solutions of the first equation equals the sum of the squares of the solutions of the first equations equal to the sum of the squares of the solutions of the second equation. So we get x1 squared plus x2 squared equals x3 squared plus x4 squared. So we can just plug this in, right? And we know that x1 squared plus x2 squared is equal to a squared minus 2 times x1 times x2, and x3 squared plus x4 squared is equal to b squared minus 2 times x3 times x4. So then if we set these values equal, we get a squared minus 2 times x1 times x2 equals b squared minus 2 times x3 times x4. Well, x1 times x2 is equal to b, and x3 times x4 is equal to a. So then we can simplify that. We get a squared minus 2b equals b squared minus 2a. And then we can solve this equation. So we get a squared minus b squared plus 2a minus 2b is equal to 0. So in other words, a minus b times a plus b plus 2 times a minus b is equal to 0. Factor out the a minus b. So we get a minus b times a plus b plus 2 is equal to 0. So we know a is not equal to b. That was given, right? So a minus b can't be equal to 0. So the second factor must equal 0. So a plus b plus 2 equals 0. So in other words, a plus b is equal to minus 2. So that's what the value of a plus b will be, minus 2. Okay, that's all I have for you tonight. So I hope you enjoyed this short tutorial. But I hope to see you during my next lesson, and I hope everyone has a good night. All right, take care.